Namaste, students! Today, we're going to talk about something that powers our entire world, from charging our phones to lighting up our homes during the Wali. Yep, we're diving into the amazing world of electricity.
I mean, have you ever really stopped to think about it? How does your phone just charge? Or a fan start spinning with just one little flick of a switch? It feels like magic, doesn't it? Well, in this explainer, we're going to pull back the curtain on these everyday miracles. So, let's get right into it.
Okay, here's our plan for today. First, we'll figure out what makes electricity flow. Then, we'll get to the golden rule, Ohm's law. After that, we'll see how circuits work, and then check out how all this stuff shows up in our daily lives. And finally, a quick summary and a little homework for you.
All right, let's start at the very beginning. We need to understand two super important ideas. What makes electricity flow, and what gives it that push it needs. If you get these two, you're all set.
So, what on earth is electric current? The easiest way to picture it is to think of water flowing through a pipe. In this case, the wire is the pipe and the water is the flow of electric charge. So current is just that flow. Simple, no? And we measure it in something called amperes.
Right, so if the current is like water, what makes it flow? It needs a push, right? Well, that push is what we call potential difference, but you probably know it as voltage. Imagine a water tank on the roof of your building. The water comes out of the tap downstairs with a lot of pressure. That pressure is just like voltage. It's the push that gets the current moving, and we measure it in volts.
Okay, now let's move on to a very, very important rule that connects everything we've just learned. This is the golden rule of electricity, the key to understanding, well, pretty much everything. It's called Ohm's law.
But before we get to the rule itself, we need to meet one more player in this game, resistance. Imagine you're trying to walk through a super crowded market street. It's tough to move, right? It slows you down. That's high resistance. Now imagine walking on a totally empty road. Super easy. That's low resistance. So in a wire, resistance is just the obstacle that opposes the flow of current. The key word here is resistance.
This golden rule comes from a German scientist, George Ohm. He figured out a really simple but beautiful relationship between the three things we just talked about: the push, the flow, and the obstacle.
And here it is, the famous Ohm's law. V equals I times R. That's it. Voltage equals current multiplied by resistance. It tells us that the push is equal to the flow times the obstacle. This formula is absolutely crucial, so please remember it.
Now, is the resistance of a wire always the same? Of course not. Think about it. A longer wire is like a longer, crowded street, so more resistance. And a thicker wire, that's like a wider road, so it's easier for the current to flow, less resistance. The type of material and even the temperature also play a big part.
So now that we know the basics, let's see how we connect things in a circuit. We'll look at the two main ways to do it, which gives the current either one path to flow or many paths.
Okay, look here. On the left, we have a series combination. The current has only one path to take. Now the big problem here is if one bulb breaks, the whole path is broken and everything goes off. You've all seen those old Diwali light strings, right? One bulb goes, the whole thing stops working. That's a series circuit. But on the right, in a parallel combination, the current has multiple paths. So if one bulb fails, no problem. The current just takes another path and the other bulbs stay on.
So which one do you think we use in our homes? Of course it's parallel. It's just so much more practical. Every fan, every light, every appliance gets the full voltage. And you can turn your TV on or off without affecting the lights. Imagine if your fridge stopped working and the whole house went dark. That's why our homes are wired in parallel.
All right, now that we know how electricity gets around our homes, let's look at two really cool ways we use it every single day.
So the heating effect. You've all noticed this. When you charge your phone, the charger gets warm, right? That's it. That's the heating effect in action. When current flows through a wire with resistance, it creates heat. It's basically all those tiny charges bumping into atoms, creating friction and warmth. Just like when you rub your hands together to warm them up.
And we actually use this effect on purpose all the time. Your electric geyser that gives you hot water, the iron box for your clothes, your toaster, your electric kettle, all of these things work using this simple principle. They're designed to get hot.
Next, let's talk about electric power. Basically, power tells us how quickly an appliance uses energy. You've seen watts written on bulbs and things, right? That's power. The basic formula is P equals V times I. The crucial thing to remember is that a high-power geyser will heat water much faster than a low-power one, because it's using energy at a faster rate.
Now, these other formulas you see here, they're all just cousins of the first one mixed with Ohm's law. They might look a little different, but they all calculate power. Which one you use just depends on what information you have. If you know the current and resistance, use the second one. If you know the voltage and resistance, use the third. It's all about using the right tool for the problem.
Wow, we have covered a lot today. Great job, everyone. Let's just take a minute to quickly recap the most important points, just to make sure we've got everything straight.
So, to sum it all up, remember that voltage is the push, current is the flow, and resistance is the opposition. The golden rule that connects them is Ohm's law, V equals IR. Our homes use parallel circuits so that our appliances can work independently, and finally, that heating effect is what makes our irons and geysers work. If you remember these 4 things, you've understood the core of our lesson today.
And now for your homework. I've got a simple question for you to think about. Why does your phone charger get warm when you use it? Think about what we learned today, especially about resistance and the heating effect. We'll discuss the answer next time. Thank you, everyone.
आज के बिजनेस वर्ल्ड में सिर्फ दिखना काफी नहीं, आपकी पहचान सुनाई भी देनी चाहिए। हर सर्विस की एक कहानी होती है, हर ब्रांड की एक आवाज होती है।
रविकांत आपके ब्रांड को देगा म्यूजिकल पहचान।
अपने ब्रांड को आवाज दो, हर दिल तक एहसास दो। हर ब्रांड बनता है विजन से, हर पहचान बनती है इमोशन से। अब मार्केटिंग नहीं, ब्रांड एक्सपीरियंस बनाइए। रविकांत के साथ आपकी सर्विस सिर्फ दिखेगी नहीं, महसूस भी होगी। नाम आपका, आवाज हमारी, पहचान बनेगी सबसे अलग आपकी। आज हम सिर्फ सर्विस नहीं देते, हम ब्रांड की पहचान बनाते हैं। वो विजन को आवाज मिलती है जब ब्रांड म्यूजिक से जुड़ता है। रविकांत के साथ हर कैंपेन मार्केट में अलग दिखता है। आज के समय में सिर्फ रिज्यूमे बनाना काफी नहीं है, जरूरी है कि लोग आपको समझें, आपकी स्किल्स को जानें और आपकी कहानी सुने। आज सोशल मीडिया पर जो दिखता है वही बिकता है, इसीलिए हम लाए हैं रिज्यूम एक्सप्लेनेशन वीडियो सर्विस, जहां आपका रिज्यूम ये प्रोफेशनल तरीके से ये आसान भाषा में समझाया जाता है। दिखो, इससे बनती है आपकी करियर रेपुटेशन और मजबूत होती है आपकी सोशल रेपुटेशन। जब आप अपना रिज्यूम वीडियो सोशल मीडिया पर शेयर करते हैं तो लोग आपको सिर्फ नाम से नहीं, आपकी काबिलियत से पहचानते हैं। क्योंकि आपकी पहचान मायने रखती है। क्योंकि आपकी पहचान मायने रखती है।